Now we start differentiation. We first of all need to understand a rule like if y is equal to x raised to power n, then when we differentiate uh, variable y, we write it derivative of the variable y with respect to the derivative with respect to x. And if the function is x raised to power n already, so we need to differentiate this as well. So d by dx of x raised to power n. So this is going to be done in a way that this power, which is n in this case, that is written first as a product of the variable x, and then we subtract 1 from the power. So this is the derivative of x raised to power n. This d by dx is actually a symbol that represents that we are going to differentiate this particular quantity with respect to change in the variable x. So we can understand it like rise over run as well. When we write it dy, that means change in y. For run, we write it dx. For change in x, that is the run, and this is the rise. This is dy, and this is dx. Okay, this was one of the rules. This rule is also applicable when there is a coefficient of x which is a non-zero coefficient. Like for example, if we have got a times x raised to power n, that is equal to a variable y. When we need to differentiate it with respect to the variable x, we write it dy by dx, and this coefficient a would first of all be intact, it would remain as it is, and then we need to differentiate x raised to power n, and its answer is going to be this one as we calculated in the previous rule. So a times n x raised to power n minus 1, that would be the derivative of a x raised to power n. For example, if we need to understand this, if we have got negative 5 x raised to power 3, that is a value of the variable y. So we need to differentiate it. So we would write dy by dx. So this is the coefficient that would remain intact. That would be written as it is. Now for x raised to power 3, we need to apply this rule, that is to write the power first, and then we would subtract 1 from the power of the variable x. So now this will give us negative 15 x raised to power 2. So that is the derivative of the given function. So with this, now we start exercise 18.11. For each of the following, find dy by dx. For part A, this is y equals to x raised to power 4. So we would apply that rule that when we need to differentiate y with respect to x, so we would write d by dx of x raised to power 4, and then the power would be written at the beginning, and then x raised to power 4 minus 1. That would give us 4x raised to power 3. That is the derivative of x raised to the power 4. Similarly, for part B, for example, which is x raised to power 6. So the only thing that is going to be changed is its power. So this is it. In this case, the power is 6. That would be brought at the start, and then 6 minus 1. So this will give us 6x raised to the power 5. Same goes for this. For this part D now, dy by dx, that will be equal to d by dx of 4x cube. I've just written that I'm going to differentiate both sides with respect to the variable x. Now, this coefficient 4 would be written intact, and now actually we need to differentiate x raised to power 3. So applying the rule that we applied on part A and B, I'm just going to bring this power at the beginning, and then it would be x raised to power 3 minus 1, which will give us 12 times x raised to power 2. Okay, in the same pattern, we have got all other parts. Let it be part I, for example. Y is equal to negative 16 x raised to the power 5 when we need to differentiate it. So I would write dy by dx and d by dx of this function of this y, which is dy by dx, that is equal to negative 16. And then I'm going to bring this power at the start, which is 5, and then x raised to the power 5 minus 1. This will be negative 80 x raised to the power 4. So that is its answer. Okay, now when we need to calculate this derivative of a function, that is actually the gradient of the tangent at a point whose x coordinate is given. So in the next question, we need to find the gradient of each of the following curves at the given point. So gradients are going to be calculated by working out the derivative of the function and then substituting for x, the x coordinate of the given point. So for question number 2, part A, y equals to x square, we need to differentiate it. So that will be written dy by dx is equal to d by dx of x squared, which is 2x raised to power 2 minus 1, which will directly be written 2x. Now, if we need to calculate the derivative of the function, which is a gradient at the given point, I'm going to calculate it at 3, 9. That will give us 2 times the value of x is 3 in the given point. So its answer is going to be 6 overall. Okay. In the same pattern, if I do, for example, part E, that will be y equals to negative 3x cubed. So differentiating it now, d by dx of this, and then d by dx of this. That will give us negative 3. This as a coefficient would be brought at the beginning as a multiple, and then I need to have the derivative of x cubed. That will be negative 3. 3 times x raised to the power 3 minus 1, that is negative 3x raised to the power 2. So that is the derivative now. And now we need to calculate this derivative at the point 2, negative 24. So derivative at 2, negative 4, that is negative 9. And now I need to replace for x, this x coordinate, that is 2, which will give us negative 9 times 4, negative 36. So this is how these questions are to be done. Okay. In the same way, we can do its part F. And finally, let me start its question number 3. It states that find the coordinates of the point at which the curve with equation y equals to 3x squared has gradient 18. Now it is given in the question that the gradient is 18. So the value of the gradient is already given to us. So we need to continue by taking the derivative. Y equals to 3x squared. So when we take its derivative, that is going to be d by dx of this and then d by dx of this. Solving it out 3 times derivative of x squared, that is 2x, that is actually 6x. So this is the derivative of the given function. Now, it is given in the question that gradient is equal to 18. So this is the gradient dy by dx. So as gradient equals to 18, so dy by dx, that is equal to 18, and the value of dy by dx is 6x, so I'm going to equate it to 6x. So that would be 18 by 6 is equal to x. That would give me the value of x to be 3. When I've got the value of x, I need to replace this value of x back into the given equation to calculate the value of y. So y will be equal to 3x squared 3 times 3 squared, that is 3 times 9, that is 27. So that is the value of y. So altogether, the final point that we had to find the coordinates of the point. So since we know that the point is written as x, y, so the value of x is 3 and the value of y is 27. So this is the point on the given curve at which the gradient is 18. So that completes exercise 18.11.